So hopefully you had enough time to try the example out on the bottom of that first page there, finding the formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. But I have the answer written behind me right here. And what this formula gives us, with the initial value of 2 and the common difference of 3, n minus 1 is the previous term, and a sub n is the term that we're finding. So, what we have found with this is an explicit formula, and what an explicit formula means is that you can go directly to the nth term instead of having to find which term came before or which term came after. So if we wanted to find the third term, for example, we wouldn't need to find the second term or the first term or the fourth term. We could just go straight to the third term by plugging in a 3 here. So 2 plus 3 minus 1 times 3 will end up being 8, and a to the n, the third term would just be 8. And that's how we can go straight to the explicit, or straight to the value we're trying to find with the explicit formula. So if we know the nth term of an arithmetic sequence and we know the common difference of the sequence, you can find the n plus 1th term, so the next term, by using the recursion formula. And this is kind of confusing because it's kind of like a math operation that we haven't really seen before, but it looks really simple. So our next term, a sub n plus 1, so we have a sub n to signify the term that we're trying to find, and if we have a sub n plus 1, that means the term after the one that we have found or are trying to find. But we know that the next term is going to be equal to the previous term plus the common difference, right? Because that's how we found the patterns in our arithmetic sequence in the beginning, is we could just go from 7 to 11 to 15 to 19, right? And we just add 4 to the term before. So that's what this formula means. It looks a little weird with the subscripts, but this a to the n plus 1 just means the entry after the one that we have found or are trying to find, which is this one right here. So it's like saying that we're going to find the third entry, and we're going to find the third plus 1th entry, which would be the 4th. So that's that equation there. Excuse me. And since finding terms of arithmetic sequences follows rules and formulas, it follows that we can perform summations with formulas that are tailored to fit arithmetic sequences. So what that means is that we can find the sum of these kind of sequences. So the way that we can do that is with this formula right here. The sum of a finite arithmetic sequence with n terms. And notice it says finite. Finite means that there's constraints on the beginning and end. So it's not going to go on forever and ever like some of our summations were. But this one is just going to be a finite arithmetic sequence. So this is given by s sub n equals n over 2 times, and in parentheses, a1 plus a2, or a1 plus an. And so s of n, let's pick this apart real quick. S sub n is going to be the sum, right? So the sum of a finite arithmetic sequence with n terms is s sub n equals. So that means that s sub n is going to be the sum of our finite arithmetic sequence. Our finite arithmetic sequence is going to be this right here. You can't see it very well on the screen, but this is the n over 2 times the a1 plus an. And what's our n? Our n is going to be the number of terms, or the term number that we're trying to find, right? And we also see n right here. And that's how we know. So when we're trying to find the term of whatever trying to find whatever term we choose, per se the 8th term. We would have an 8 right here at the subscript n, and we would also have an 8 in the numerator over the 2, because that's 2 different n's. Our a, and let's go with our a1, and the beginning of those parentheses right here. A1 is going to represent our initial term. So the sequence's first term is going to be A1. So initial term is what we'll call it. We use I most of the time because it stands for initial. And so that's a way you can remember that as well. It's N in this case, but most of the time when we have AI, or when we have the summation with the I on bottom, that means the initial term. So A1 is going to be the initial term, and AN, like we said, is going to be the term that we're trying to find. I'll call it term number n. So if we substituted a number in for n, we would have term number 8, or term number 3, or term number 1 million. And that's how we could generalize that and find the sum of a finite arithmetic sequence. And here's what those variables would stand for. So let me erase all this jazz. And let's try finding the sum here. So the sum of the first n terms of an infinite sequence is the nth partial sum. The nth partial sum can be found by using the formula for the sum of a finite arithmetic sequence. So we'll find the sum of the first example right here. So first things first, we can figure out how many terms. So So n equals the total term number, or the number of total terms. So I'll write that in here too, the total term number. So to find n, we're going to count all these terms up. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say that n equals 10. And our initial term, which we also know and can find very easily, represented by a subscript 1, is going to be 1, because 1 is our initial term. Our last term, so our a sub n, since there's 10 terms, a sub n is going to be a sub 10. And a sub 10 equals what? 19, right? So now we can just plug all of this into this formula here. And so we know that the sum of 10 entries is equal to n, which is 10 over 2, times a1 plus a10, which is 19. So when we solve this equation out, we get 5 times 20. 5 times 20 is equal to 100. So the sum of this sequence here, this arithmetic sequence, because it has a common difference of 2, the sum is going to be 100. So why don't y'all try the next one on your own? It might look a little different because it isn't a list of numbers, but I'll tell y'all right now. I'll find a place to write. If we have the summation symbol, it can still be pretty easy for y'all to figure out. So we have our initial term down here, right? We've got our final term up top. So this will be our n. This will be our I, our a1. Our sequence will be 50 minus 2n. And so we've got our n here, we've got our initial value, and then we'll just have to find our last value. And then from there we can create the formula, and we can solve for the sum of 50 terms of that arithmetic sequence. So I hope y'all understood that. I'll have y'all do that example and then the next example, and we'll go over them in class, or we'll discuss them, make sure we have the right answer. And then after this, we will kick off section 9.3. So I'll catch y'all later.